the long-awaited moment has arrived. The scientific mission is approaching the surface of Mars. Thousands of specialists around the world are glued to their monitors. At stake are tens of millions of dollars, years of hard work, and humanity's dream of seeing new worlds with its own eyes. The mission's name is Mars Climate Orbiter. In the late 90s, this NASA project was supposed to be a breakthrough in the exploration of the Red Planet. Its mission was to send fresh images of Martian landscapes back to Earth and uncover the secrets of the planet's atmosphere. The spacecraft was assembled, tested, and sent on a journey hundreds of millions of miles long. No one suspected the tragedy was lurking in one of the formulas. A barely noticeable misalignment arose between NASA departments and the contractor Lockheed Martin. Engineers in one division calculated the spacecraft's movement parameters in pound force, that is, using the imperial system, while another department continued working in newtons, as is standard in the metric system. It might seem like a minor detail. In practice, it turned into a catastrophe. On the 10th of September 1999, the countdown began at the control center. The Mars Climate Orbiter entered the final segment of its trajectory, fully switching to autopilot control. Specialists observed as the data began to diverge from the calculations, but they didn't have time to intervene. The probe abruptly enters the atmosphere, descends too deeply, and within minutes is completely incinerated, unable to slow its motion. All the data, equipment, photographs, absolutely everything disappears without a trace. This was not just a technical failure, it was a blow to the prestige of the entire American space program. The loss of a research probe worth $25 million happened before the eyes of the entire scientific community. The investigation uncovered a shocking truth. A mistake in converting units of measurement was the cause of the mission's failure. The transition between systems was so subtle that even experienced engineers missed it amid the complex calculations. While specialists analyzed the smoldering wreckage and the illusion of flawless missions, in other laboratories, the search for ways to get closer to the future continued. Sometimes this led to astonishing, and at times truly dangerous, results. Flying cars and falls from the sky. The price of dreaming about the future. While some of humanity's dreams burned up in the atmosphere of a distant planet, on Earth's roads, engineers were working on an even more ambitious idea car that could fly. The post-war era in the United States was marked by a tremendous surge of interest in technology, and it seemed that flying cars were only a matter of time. Prototypes began to appear as early as the early 1950s. One of the first attempts was the Aerocar by Mo Taylor, which was a hybrid of a passenger car and a small airplane. When folded, the device resembled an ordinary car, but once the wings and tail were attached, within just a few minutes, the pilot could take to the skies. The first public demonstration of the Aerocar took place near the city of Longview, Washington, and caused a sensation. Spectators watched as the car started up, drove down the runway, and took off right from an ordinary road. But the initial successes were quickly replaced by concern. Piloting a flying car was much more difficult than operating a regular airplane or car. Not only did you need a driver's license for this, but also a full-fledged pilot's license. By the early 1960s, the first tragic news stories began to appear. During a test flight, a similar vehicle, the Amphibian, crashes due to a wing mount failure. The car crashes in a field, and the pilot sustains serious injuries. Engineers begin to consider the issue of reliability. Wings that could be detached manually became the Achilles' heel of the design. Any loosening of the fasteners or poor assembly almost inevitably led to disaster. The race for the future was not limited to the United States. In Europe, engineers at Citroën were developing their own version of a flying car, equipped with a rotary engine and folding wings. In yet another demonstration, the project failed. Due to a miscalculation in weight distribution, the prototype lost control in the air and, before a stunned audience, fell from a height of about 150 feet, nearly wiping out the entire development team. Despite these setbacks, the researchers' enthusiasm did not fade. In the 1970s, the MISAR project appeared, developed by American engineers, in which the body of a Ford Pinto car was combined with the wings of a Cessna airplane. However, during its very first public demonstration, the structure fell apart in mid-air. A wing separated from the body, and the vehicle with the pilot crashed onto a gas station in California. The explosion completely destroyed the project and claimed the lives of both inventors. As a result, with each new attempt, the idea of a flying car only proved how dangerous it was. Transformations were too complex, there were weak points in the design, and the cost of any miscalculation was extremely high. The dream of freedom to travel in the sky turned into real accidents, loss of life, and enormous financial losses. But it wasn't just transportation innovations that brought catastrophic consequences to the scientific world. Even more frightening were the experiments with new chemical formulas that promised to cure millions. Chemistry of disasters. Medicines that turned into tragedies. In the 1950s, the pharmaceutical industry around the world was experiencing a real boom. Scientists were discovering new compounds, testing formulas, searching for universal cures for diseases that had plagued humanity for centuries. One such development was led by the German company Chemie-Grünenthal. Their new drug, thalidomide, was marketed as a harmless sleeping pill capable of relieving insomnia and anxiety. Manufacturers assured doctors and patients that the drug was so safe it could be prescribed to pregnant women to relieve morning sickness and help them sleep. Millions of packages appeared on pharmacy shelves across Europe, as well as in Australia, Canada, and Japan. Within just the first few months after the drug became widely available, doctors began to report strange cases. Newborns began to exhibit severe limb deformities, with missing parts of arms and legs, and malformed internal organs. Over the following year, the number of such infants increased rapidly, and only by the early 1960s did it become clear that thalidomide was the cause of the catastrophe. In total, more than 10,000 children were born worldwide with severe birth defects, and according to experts, the actual number of victims exceeds 15,000. In the United States, the drug did not have time to become widely distributed thanks to the meticulousness of Dr. Francis Kelsey, who refused to approve the medication without additional research. This decision saved thousands of lives. But in many countries, the tragedy had already unfolded in full. After the scale of the disaster was revealed, an urgent recall of thalidomide from pharmacies began, along with lawsuits and the revision of drug testing standards. The manufacturing company paid out multi-million-dollar compensations. However, the consequences for thousands of families were already irreversible. National regulators introduced new laws requiring much stricter clinical trials, forever changing the approach to drug development. However, thalidomide was not the only example of catastrophic mistakes in pharmacology. In those same years, a drug called clostridine appeared in the UK, marketed as a treatment for diabetes. Just a few years after its launch, widespread cases of bladder cancer began to be recorded among patients who had taken this drug. Production was halted only after official investigations and confirmation of a direct link between the drug and the rise in cancer cases. Equally devastating was the introduction of the drug vincristine into medical practice, which was supposed to be a revolutionary treatment for childhood leukemia. However, violations of dosing protocols led to severe poisonings, paralysis, and the deaths of dozens of patients, all due to technical errors in the instructions. Mistakes in chemical formulas, rushing new drugs to market, and insufficient testing all of this resulted not only in scientific failures, but also in real human tragedies that forced a re-examination of the very foundations of the healthcare system. But even more dangerous consequences could arise where experiments touched upon the very foundations of life itself. After all, in their quest for absolute control over genetics, scientists sometimes unleashed creations that could no longer be stopped. Genetically modified monsters. When science got out of control. At the end of the 20th century, genetic technology seemed like tickets to the future. The ability to rewrite the structure of living beings promised freedom from hunger, disease, and even death. Scientists all over the world plunged into a race to create new forms of life, not for art or entertainment, but for science, economics, and power. The first alarm bell rang in the United States, when a team from the University of California, Berkeley brought super mice into the world. These rodents displayed extraordinary aggression and enormous size, something that had never been achieved through conventional breeding. The mice have accelerated metabolism, their muscles are almost twice as large, and their behavior becomes so unpredictable that laboratory staff are forced to reconsider standard safety measures. The experiment of integrating the gene responsible for growth hormone production results in the emergence of a new type of animal, which escapes from their cages at the first opportunity. Photos of the giant mice make their way into the press. A scandal breaks out. But the research continues. Meanwhile, in the 1980s, British biologists create the famous sheep Dolly, the first mammal, to be fully cloned from an adult cell. Although Dolly is born healthy, she soon develops arthritis and lung problems. A few years later, the sheep has to be put down due to illness. It turns out that cloned animals age faster, are prone to cancerous tumors and pathologies, and that cloning technology is far from perfect. Despite setbacks in laboratories in Russia, France, and China, scientists continue their experiments, resulting in dozens of deformed clones being born. Calves without limbs, piglets with 2 heads, rabbits with deformed organs. By the early 2000s, a new era begins. Genetically modified mosquitoes created by the company Oxitec were supposed to defeat dengue fever in Brazil. A special gene is introduced into the mosquitoes' blood to shorten their lifespan, aiming to reduce the number of pests. But just 2 years after millions of these insects were released into the wild, the opposite effect began to occur. Hybrids appeared that were resistant to the new conditions. Some individuals even increased their reproduction rate. The authorities are forced to intervene, and the large-scale use of the technology is suspended. A similar story unfolds in the United States, where a biotechnology corporation releases a batch of mutated oysters into Tampa Bay, Florida, which was supposed to grow quickly and purify the water. At first, the effect is impressive, but after a few months, the oysters begin to develop pathological cancerous growths, leading to the mass death of the local population. Failures with living organisms are not limited to animals alone. In China, researchers are trying to introduce an artificial gene into rice to increase its resistance to pests. After the first fields are planted, it turns out that the new variety causes severe allergic reactions in farmers working without special masks. Production is halted, the seed stock is destroyed, and regulators introduce new restrictions on testing such crops. Mistakes in genetic engineering lead not only to financial losses, but also to unpredictable changes in the environment. Driven by the desire to be first, companies and universities accelerate the pace of research, forgetting the need for lengthy trials. No sooner does one scandal die down than the next one appears in the news. Now, the discussion is about devices capable of affecting the fate of entire cities. Nuclear trains. Why a brilliant idea almost ended in disaster. While news of genetic experiments was causing concern in scientific circles, a completely different yet no less dangerous project was emerging on the railways of the United States and the Soviet Union nuclear trains. In the 1950s and 1960s, military engineers were searching for ways to combine the mobility of rail transport with the power of atomic energy, dreaming of creating a train that could travel thousands of miles without refueling, supply entire cities with electricity, or even launch ballistic missiles directly from the tracks. In the United States, the project was called ML-1. A compact nuclear reactor is installed in a railcar that, from the outside, is indistinguishable from a regular locomotive. The reactor-powered turbines generated electricity and the heat exchange system was contained within a sealed capsule. The idea seemed fantastic. First and foremost, there were military advantages. Such a train would not need traditional fuel, could travel for weeks along any routes, hide from satellites, and suddenly change its position. American generals planned to place mobile missile launchers, medical laboratories, and command centers on board. At the same time, the Soviet Union was developing nuclear locomotives under the LTS and OP-1 projects. They were also building test railway loops for the initial trials. However, behind the impressive picture lurked new and frightening dangers. During the first tests of the ML-1, it became clear that the cooling system could not handle the thermal load. When accelerating, the train overheats, the temperature inside the carriage rises rapidly, and the radiation levels exceed safe limits. Specialists urgently and hastily shut down the reactor. Engineers detect steam leaks containing radioactive particles. In the Soviet Union, the first launch was accompanied by similar problems. Automatic sensors detect excessive radiation, and the train is stopped after just a few miles. Nevertheless, the tests continue. The next stage in the United States is to run the train through densely populated areas. According to official documents, the tests take place in the Nevada desert, but unofficially, the train crosses areas several times where residential neighborhoods are located within a 20-mile radius. Errors in calculations lead to the release of radioactive steam into the atmosphere, which only becomes known many years later when the archives are declassified. Engineers try to improve the design, reinforce the walls, add special filters, and invest millions of dollars in new lines of defense. In the Soviet Union, the project goes even further. Engineers build a fully operational armored train to transport nuclear missiles and plan to conduct a nighttime experiment by running the reactor at full speed. During transportation, the train suddenly loses control on a turn, and several cars derail. There was a real threat of the nuclear compartment being breached. Radiation danger looms over dozens of villages. Only the quick work of repair crews and strong protective casing saved the country from an environmental disaster. As a result, both projects are shut down by the early 80s. Officially, the reason is the excessively high costs, unsuccessful tests, and environmental risks. The reactors are dismantled, the train cars are decommissioned, and the documents are sent to secret archives. However, it soon became clear that the combination of nuclear energy and transportation turned out to be not only impractical, but truly dangerous. Once again, scientific progress was approaching the brink of disaster. And if it weren't for timely decisions, the consequences could have been much more dire. And yet, despite the failures with nuclear locomotives, researchers' attention shifts even higher to near-Earth orbit, where experiments are already underway that could change the entire course of technological development. Star Wars in orbit. Experiments that nearly caused chaos. It was precisely near Earth orbit in the 1980s that a series of experiments began, which could have literally turned space into an arena of chaos. The universe had always seemed safe and infinite to humanity. But everything changed when the military and scientists began launching devices into space, whose purpose was not just research, but a demonstration of power. The United States, as part of the Strategic Defense Initiative program, or as journalists dubbed it, Star Wars, conducted secret launches of satellites equipped with new experimental laser and radar systems. One of the most well-known incidents occurred in the spring months of 1983, when the DSCS-3 satellite unexpectedly stopped functioning, and a series of bursts of electromagnetic interference were detected in orbit. On the same day, Soviet scientists reported temporary malfunctions in the operation of their own military satellites. Suspicion falls on a failed test of an experimental United States weapon. While all attention is focused on these incidents, work is underway in the Soviet Union on the Polyus-Skif system, the world's first laser satellite, designed not only for defense but also for the possible destruction of other space objects. In June 1987, the device is launched into orbit using the Energia rocket. Due to a programming error, the stabilization system fails. The satellite suddenly veers off its intended trajectory. The unique laser falls back into the atmosphere and burns up, never having demonstrated its capabilities, but leaving thousands of small fragments in orbit, posing a huge danger to all future missions. But the race does not end there. In the United States, the Solar Power Satellite project is launched, aimed at directing powerful radio signals to Earth to generate energy. However, the antenna's design turns out to be insufficiently stable, and the signals begin to interfere with the frequencies used by civilian air transport. For several weeks, pilots report communication disruptions, and the government is forced to urgently suspend the experiment to prevent plane crashes. An even more dangerous attempt was the test of the missile defense system, in which small missiles with warheads are launched into orbit and are supposed to seek out targets on their own using radio signals. During one of the tests in 1986, a missile lost its orientation and nearly collided with an active weather satellite. The collision was prevented just minutes before disaster struck. To do this, it was necessary to urgently change the trajectory of both spacecraft. At the same time, other countries are also trying not to fall behind. France, Japan, and China are launching their own satellites with experimental engines, many of which fail within the first few months, leaving behind clouds of space debris. In the 1990s, one of China's satellites exploded in orbit, creating tens of thousands of fragments, some of which threatened the International Space Station. And when China conducted an anti-satellite missile test in 2007, the whole world watched as a massive cloud of debris spread across orbit at speeds of several miles per second. Such failures forced the international community to sound the alarm. The first agreements on satellite disposal are introduced, standards for launching objects into orbit are revised, and the military is given strict bans on testing new weapons in space. Despite the tremendous losses and the real threat to the entire space community, it is precisely these events that become a lesson for future generations of engineers and scientists. Even the greatest technological ideas require utmost caution and responsibility, otherwise the price of a mistake can become catastrophically high.